Time of flight. The time of flight is defined as the time taken by the projectile right from the point of projection till the projectile reaches the ground. So that is the time of flight. So this time of flight, it is denoted by the letter t. Now let us derive about the equations or the formula of the time of flight. Okay, so for vertical distance, okay, when the time is capital T, it means the projectile is at point B. So therefore, using these equations of motion for vertical distance, S here at this point B, how much is the vertical distance? It is equals to 0. Is equals to U. U because we are talking here about vertical, so you mean Uy. Instead of T, it is the time of flight plus half. This acceleration, it is the accelerations along vertical, that is Ay. And instead of capital T, we can write, instead of small t, we write T. Next, 0 is equals to, what is Uy? Uy, it is the vertical component of the initial velocity u along y-axis. So that is equals to u sine theta plus half. How much is ay? We know ay is equals to minus g and then t squared. Or if you take this term to the left, you will get half g t squared is equals to u sine theta. Or just t squared, it will be twice u sine theta upon g. Or just t, it will be equals to root over twice u sine theta upon g. Okay, so this is the expressions of the time of flight. Okay, is there any, okay, I think I miss out t here. This t should be here, sorry. So with this t, that means we have t here. So this t with this square cancel, so no more square. So you'll have only just this much. So this is the time of flight. Okay, so let me name this as equation 1. Fine. Next, time to reach maximum height. Let me write it as Tm. Okay. Now, this time to reach this maximum height, it is actually the time taken by the projectile to reach this point A in this figure. So this point A, it is the maximum height where the particle can go up. And after this point, it has to fall down. So this is the maximum height. It is equals to hm in this case. The maximum height is how much? Hm. Now, because this point A, it is symmetric, which means the distance from O to A is the same as A to B. So therefore, the time at this point A, it should be half the time of flight. So if I denote that time to reach the maximum height as Tm, then this Tm, it should be equals to half of time of flight. That means T upon 2. So therefore, I can say the time to reach the maximum height is equals to T upon 2, or this is equals to twice u sine theta upon g, which is the value of t, and then you divide by this 2. Okay, so this 2 with 2 cancel, so this time to reach the maximum height, it is equals to just u sine theta upon g. Okay, so this is the time to reach the maximum height. Let me name this as equation number 2. Next is horizontal range. This horizontal range, it is the maximum horizontal distance in which a projectile can cover. In this figure, if this is the the projectile in which it is projected from this point O, now it goes like this and it come at point B. So this distance from O to B, this is known as the horizontal range. Okay, so we denote that horizontal range by capital R. Okay, Now let us derive about the expressions for the horizontal range by using again this equation s equal ut plus half at square. Now for horizontal distance, okay, we have, instead of s we have x, u mean ux, and then d. What is d for horizontal range? The time which is taken to cover that maximum horizontal that horizontal distance, it is equals to capital T. So instead of small t, I'll write capital T plus half. Instead of a, I'll write ax, and then instead of t, I'll write capital T. But since you're talking about horizontal range, this x is equals to how much from here till here? It is equals to r, and ux is equals to u cos theta, and then capital T plus half. What is ax? Ax is 0, and then t square. So this will disappear because of the presence of the number 0 here. So just r will be equals to u cos theta into t. Okay, but we have seen about the expressions of capital T, and this t is equals to how much? T is equals to twice u sine theta upon g. So putting the value of t here, you will get r equal u cos theta into twice u sine theta upon g. Or we can say r equal, now I'll write in this way, u into u mean u square. Now this is 2, then I'll write sine theta cos theta upon g. Just rearrangement of the term in this case. Or r here is equals to u square, but we know from maths that 2 sine theta cos theta is equals to sine 2 theta upon g. So this is the horizontal range. I'll name this as equation 3. Okay. Now, let us see about what is the condition for the horizontal range to be maximum. So, maximum horizontal range. Okay, let me denote that by Rm. See, because we know this horizontal range as seen in this equation, it depends on sine theta and sine 2 theta. So that means, in order that this R is maximum, this sine 2 theta should be equals to how much? Should be equals to 1, because the maximum value of sine theta is equals to 1. So for maximum horizontal range, this sine 2 theta should be equals to 1. Or we know sine 90 is equals to 1. So therefore this 2 theta, it should be equals to 90 degree, because sine 90 is 1. Or I can say theta is equals to 45 degree. Okay, so this means that in order to get a maximum horizontal range of the projectile should be projected at an angle 45 degree with respect to the ground. Okay. Now, what is the expressions of the maximum horizontal range? Okay, so if sine 2 theta is equals to 1, then your equation 3 will give you how much? Your equation 3 will give you r. Now it becomes maximum, so we write Rm is equals to u square upon g. U square upon g. And then sine 2 theta for maximum horizontal range is equals to 1. Or I can say this Rm, which is the maximum horizontal range, is equals to u square upon g. So this is the expressions for the maximum horizontal range. Fine.